All right, so usually when people think of, come on little guy, what do we got? What'd you hang? There we go. All right, so usually when people think of being able to have visibility into some HTTP or HTTPS connections that their code is making, a lot of people think of things like, say, Firefox or Chrome web dev tools. So this is like the network tab. Here is all of the HTTP requests made to render this page, including all the CSS, the JSON, all of those kind of things. The fun part that I've had over the last 10 years building software is I've spent a hell of a lot of time building back-end software. And a lot of it these days is no longer one large monolithic app and hasn't been for some time. In order to get any job done, usually you have to call out to extra services. And when things go wrong on, say, interaction number 6 of 10 interactions you need to maybe satisfy a single request, and you don't have any visibility on that because either your logging's inadequate or something else, it's kind of frustrating. And one of the first things that I reached for when I first found this kind of situation was logging. All right, let me log every damned request that I make to disk, trace it back to the request that's made in the first place, and hopefully then I'll be able to understand the situation. What you get is an enormous situation of lots and lots and lots of logs that maybe you get a chance to read, maybe you get a chance to search, maybe you get a chance to understand. Ultimately, on at least one project, or on the first project where I really kind of was bashing my head against this, I reached for and found man-in-the-middle-proxy. Now, what is this thing? What can it do? Ultimately, it can intercept all communication, not just over HTTP, but over HTTPS, between anything that speaks HTTP. It can capture all of the details of any request and any response, decrypting things along the way, potentially altering the request before the server ever sees it, potentially altering the response before the client ever sees it. So at a certain point, you can lie to both sides of the equation if you want, if you're willing to, and neither side necessarily has any idea you're doing this. So how the heck, well, I'll get into how in next slide. But so a little more on its features. It supports all versions of HTTP, including HTTP 2. There's been work via the last couple of Summer of Codes to provide that. It's got multiple front ends. The terminal-backed one that uses Erwid, which I'm mainly familiar with and use most of the time. And another one that has a web browser-based front end. Not as full-featured, but if you're just getting started with it or just want to inspect the traffic that's passing from, say, your Python or Ruby code running on a server to other services, this is going to let you do that and not necessarily provide you all the features that the Erwid-based front end would, but be a lot easier to use and not necessarily complicate your life. The tool is also completely open source, freely available, and scriptable and extendable in Python 3. The other tools that are available for this, like say Mitmproxy or Charles Proxy or Fiddler on Windows, those aren't free. And that kind of bothered me at a certain point, particularly since I was on a project with very shallow pockets for anything other than my salary. So, how does this thing actually do its job? What it basically does is, at least in the manner that I'm configuring this thing, you configure the client so that it routes all of its traffic through man-in-the-middle proxy, using it as a proxy for all its HTTPS or HTTP or HTTPS traffic. And because you're doing that, it actually gets to see all of the setup that you're doing for the HTTPS connection with the backend service. It's going to be able to sniff the certs that are used on both sides, and the client's going to trust this cert. How you actually get that client to trust the cert is something I'll get into a little bit later. There's a heck of a lot more details on this link. Whenever I post the slides up to you guys, probably after a little bit of cleanup, you feel free to take a look. So, first example that I had from maybe earlier last year, I have a bunch of, can you guys still see that okay? Yeah, let's jack that up a little bit. How's that? Still good in the back? Speak up now. All right. So the first thing is I had a bunch of files that I needed to pull out of S3 and effectively clone back into S3 in different keys. You could do this with different buckets. In my case, I needed to do it in the same bucket. So I needed to hack up some Python code to do this. What I wanted to avoid was being able to having to pull all of this data down out of S3 just to shove it back in. Kind of irritating, would waste a lot of bandwidth just to put it back there. So what I found searching through AWS's docs and their HTTP API is a header that you can put on a put request that has a value of XAMZ copy source. In that you put the bucket and the key that you want to copy, and S3 will handle the retrieval of that from that bucket and put it into the destination bucket for you. What my problem was when I tried to look at how AWS, at least in version 4 of the S3 API, handled signing, I got a little confused and a little frustrated and said, dang it, I don't want to use this. There's a nice library for this in Python 3 called Botto3. I just want to use that, but I don't know if it's going to do the right thing. How the heck can I actually see what it's doing? It's talking over HTTPS. There's no way I can watch it, except for the fact that I have man-in-the-middle proxy. So this is the basic hacked up code that I came up with in maybe 15 minutes of screwing around with Botto3. And ultimately what I discovered once I executed it, passing in these various environment variables, what I found was that Mitmproxy was properly capturing the content since they were using requests. I took a guess by taking a quick look at their source.
Make that page bigger, Ross.
This guy? Oh yeah. This can get a whole lot bigger. The page or the terminal? Come here, buddy. All right. So we can see we have 2 requests. I got a head request. That's not going to have any content. No real worries there. And oh yeah. Don't worry. It's going to be real big once we dig into the details of each one of these requests. So that's the head request. In the put request, just below it, I see my XAMZ copy source, the header that I'm hoping that it would actually do, and it's properly formulated. So I know my Python code works, and I was able to verify that it worked by simply watching the traffic that passed over the wire to S3. So what's in those environment variables? The first one, Mitmproxy, says, hey, client code, send any regular HTTP traffic you've got through this service. When man-in-the-middle proxy starts, you'll see down here in the lower right, hopefully that's showing up right down here, that it's listening on localhost on port 8080. So from that, I knew, all right, I need to redirect all my traffic for HTTP through port 8080. Same with the HTTPS traffic. The interesting part is this request CA bundle environment variable. Requests can take an extra bundle to look for and trust as a set of known certs rather than default root certs on the box, or certify the bundle of root certs that requests will read by default. You can override that and as a result get requests to trust the fake CA that man-in-the-middle proxy will generate. And thus you get to see private traffic in the clear. Really cool. So, next example. Python standard library. You generally don't use it. Everybody leans out for requests, but I kind of included this one just for completeness. So the environment variables are slightly different. I'm going out to this really simple JSON-based, a little warm. I'm going out to this JSON-based API, pulling down some JSON, and I'm going to pull some data out of that JSON. So let's go into a terminal, and all right, let's get a terminal then. Oh, I got the wrong one. Okay. Sorry, I was literally preparing this presentation right up until the minute I stepped in the door. Not usually a good sign, right? Okay. Yeah. How does one exactly type holding a microphone? All right. So Thank you, man. Activate my VM. All right, so now I need my notes here. We're going to snag this, which is my first example. Paste it in. And of course, I'm not actually connected to the network. Anybody got details for that? Oh, thank God. Much appreciated. Let's see. Please don't curse me, demo gods. All right. So, still cursed. Why am I getting a connection refused? That's no good. Looks like I got an IP address. Perhaps man-in-the-middle proxy is screwed somehow. Ah, that'll do it. There we go. It's trying to connect to the proxy and not actually succeeding. So now I get an HTTP 403 forbidden. Why am I getting that? As it turns out, the person who built this API does not like getting hit by the Python standard library. All the way down at the bottom here, we can see the owner of this website has banned your access based on your browser's signature. Kind of frustrating. What's my browser's signature? I'm just using the Python standard library. Turns out that's actually this user agent that's betraying me. Fortunately, man-in-the-middle proxy can lie. As I earlier said, it can alter requests on the fly before the server ever sees it. So I'm going, say what? Oh yeah. Yeah, and don't worry, I'm going to be using this window for man-in-the-middle proxy all night, so it'll stay large. Sorry about that. I'm going to set this guy down real quick and fix the issue real quick. Now, how this is actually working, I'll get into a little later, assuming there's time. Ah, crud. Just my luck. All right, so we have this. Run this guy again, get our traffic in here. Okay. All right, so now you see this replacing down at the bottom. What it's actually replacing, we'll get into, but the key thing is man-in-the-middle proxy is now going to apply some transformations to the request. So I'm not going to alter the code at all, and now I'm going to get a 200 error, or 200 success. So I actually have JSON data now. And you'll notice the main difference between this thing and the request is now I have a user agent that is, clearly legitimate. Hooray! So now the site won't block me. Awesome. So back to my slides. So we can take a look in our options for man-in-the-middle proxy and see what the heck my configuration load actually did. This is the transformation that it's applying in man-in-the-middle proxy ease. This tilde HQ says, all right, match a header. This expression after it tells it which header, so match the user agent, look for this regular expression, python-urllib.star, anything starting with python urllib, replace it with legit user agent, and as a result, you see what you've got in front of you. Valid code. Hooray. So now we're going to get rid of those replacements because the site doesn't seem to have a problem with requests. Hooray. Whack that guy. And Let's move on to my next example with requests. Since I'm using requests, I can do a little more. I don't have to parse a bunch of JSON and screw around in the Python standard library. I can get requests to do it for me. So I'm going to ask for the same character. I'm going to crawl into that JSON and grab a piece of data and use it to get a new URL to retrieve. And then I'm going to call that new URL. So in order to do that guy, we're going to grab this. That's what I get for being left-handed. So now we've requested this. We have the same request. We've made it through. Request is flowing through in the same way, and I have one slightly different environment variable to tell requests, as earlier explained, to trust man-in-the-middle proxy cert again. So if I wanted to, with man-in-the-middle proxy, since I can edit both the request and the response, I don't know how I'm going to do this with one hand, but we'll find out. So if I wanted, say, to alter this request or response to prove that I can, I'm going to get rid of this guy. I'm going to edit this. I'm going to say I want to edit the response body. And here's where it gets fun. Because using Vim with one hand, I don't think this was necessarily a use case the creators ever really envisioned. Hooray. All right, that's the fun part. So originally I was requesting this URL afterwards. I'm going to change this to something a little bit more visible, say something like 100. No, I'm good. I think I'm good. Finally lost some of the nervousness. I haven't given a talk at Chippy in something like 5 years, so it's been a little bit. All right, so we're going to do it again, and it didn't work. So the one thing I forgot, I altered my request, but what I didn't set is this request should be server-side replayed by man-in-the-middle proxy, by which, oops, not duplicate. So I want to replay just this one. This is a shortcut that you'll find in the man-in-the-middle proxy docs to say this one that has the two greater than signs, the one that's currently selected, replay that one. I could just as easily replay all of them if I say all here, but I really only need it to replay this one. So I'm going to, again, not changing my code, make this, and I see my new request being made. So from this, I can get any piece of code to do relatively whatever the heck I want. So if I really want to exercise a piece of code, probably before I'm writing tests or stubbing those things out, this would be a way to do that. Or say, emulate behavior that some backend service that I'm writing against is supposed to have soon, anytime now, but it's not there now. I can kind of dummy that up with man-in-the-middle proxy and be able to write code against it and have some confidence that it's working properly. Or in the case of some projects in the past where we weren't allowed to write tests, at least snapshot, take a snapshot of what the HTTP requests or responses that code had to run against in the past, make sure it still does, even with all of the changes that we might have made to accommodate some new feature. Wouldn't recommend that kind of development, by the way. All right, so we can now man-in-the-middle both URL-lib and requests, and you've got a couple of recipes there to be able to do that. So another use case that I found this for was a developer on my team was calling a backend service, and somebody hadn't fixed the CORS policy on that service yet to a point where you could actually write code against it. So he was completely blocked, couldn't do a damned thing until somebody on their side fixed it. And when we'd call them, they say, oh, well, so when are you guys going to fix it on your side? Never going to happen. So what I ultimately came up with as a short-term fix for this guy was a simple invocation of man-in-the-middle proxy. You run this, it's going to perform a couple of transformations on the request coming from his browser, rewrite his origin to one that's acceptable by their service, rewrite the access control allow header origin that's coming from the busted service with the busted CORS configuration that doesn't like us yet, and be able to actually unblock him and get him so he can write some JavaScript code and knock out the feature we really need him to knock out. And eventually demonstrate to managers why they need to talk to the managers within their team and get that service fixed. All right. So, wow, that went quick. Eep. So where the hell, some of you might be wondering where the heck I got that SSL cert environment variable from the Python standard library. This will actually tell you, if you call it with Python 3, what paths that SSL actually looks for. One of those things can be an environment variable. If your Python's compiled against OpenSSL, then OpenSSL in all likelihood will pay attention to that SSL cert file. It's supposed to also pay attention to a set of, or a directory of things, but I couldn't get that to actually work on this Mac. Good luck. I couldn't actually get it to work in Debian Stretch either, so good luck anybody trying to do that. At least you've got one working recipe. Cheers. There's a lot of references in the Mitmproxy docs that can describe a whole lot more about its capabilities and go into a lot more detail than I've gone into here. Let's see, the last thing that I've got. So you like what you see here, you want to be able to inspect traffic for yourself, hopefully not manipulating it for nefarious needs. How do I get a hold of this thing? They provide statically compiled binaries. Despite the fact that it's a Python library and it's somewhat easier to install than it used to be, it's still got somewhere in the neighborhood of 30 or so dependencies, some of which require headers. So it can be kind of a pain in the ass getting a hold of those, or at least it used to be. So they've got statically compiled binaries that you can pull down for Windows, Mac, Linux, boot those, start playing with it. They also export a Docker image that they maintain officially. So if you want to play around with it through that, you can do that. It's particularly useful if you want to be able to man in the middle any traffic that a Docker container is doing, to maybe keep an eye on the thing and make sure it's behaving itself. So some caveats. If the client library, sorry, I'm going to regress into the horrible things to do during a presentation, read my slides, but some client libraries, if you're trying to debug what could be going wrong with them, they could be pinning the cert. One example of this would be Braintree. This is where they keep a copy of the cert, usually one with an incredibly long timeline before it expires. They'll keep a copy of that inside of the library and set requests, or whatever HTTP client they're using, to verify that the cert they get back from a service is actually that cert. If you really want to inspect the traffic in that, you basically have to edit the code. If you don't have the code, you're kind of screwed. The best thing to do is actually use the ignore host parameter, because otherwise man-in-the-middle proxy is going to try and lie to that client library and say, oh, I'm really that service. The client library is going to know the difference and completely fail, usually with a cert verified error. The latest version of man-in-the-middle proxy crashes a great deal more than the versions I've been using over maybe the last year. So if you really want stability, or you want to be able to dump things reliably and maybe be able to open them in the latest version, you can open older dumps generated from, say, man-in-the-middle proxy 0.18.2, which is considerably older, but ships with Debian Stretch and I think Ubuntu Trusty as well. So it's probably the easiest thing to install if you use the repositories in your Linux distribution. Another thing to keep in mind, all traffic in dump files is captured in the clear. So you basically stripped all of the protection that you usually have for all of this information off and saved it into a file on disk. You should probably kind of guard those and make sure they don't slip into the wrong hands, because maybe you've got personally identifiable information for those. The real recommendation to prevent that kind of thing is don't man-in-the-middle production. Use it in dev. It's a lot safer there. A lot less harmful data travels through dev than should travel through a production server on most days. Another recent development that I found while preparing this presentation, while I'd never really had a problem doing this before, Android 7.1 Plus broke the ability to trust user-level certs. That is, certs that are installable by a non-root user. So you have a couple of options. One, you can rip the APK out of the phone if you really want to man in the middle of the thing and see what it's doing, and then apply a couple of tools to it to make it think it's a debug build, and then jam it back in the phone and run that build instead. There's a lot more discussion of why this happened and the various tools you can use to circumvent this. I haven't tried any of them because I had enough interesting times just trying to prepare this presentation and make it fit in a half hour. So lots more details on this man-in-the-middle proxy issue. Another thing, the latest version crashes quite a bit, as I mentioned before, but the developers are extremely active. They're already jumping on those fixes. As I was working on this presentation over the last week, I noticed that like 3 days ago somebody had found all of the bugs that I had already found and was already submitting patches and fixes that were already landing in master. So very soon we should have a release that's actually fixed these issues. Again, if stability is a problem for you, use an older build. They're a lot more stable. So with that, I'm going to open the floor to questions because I'm hoping there's at least a few. Anybody? All right. Go ahead, sir.
Would this be able to intercept traffic that I'm already tunneling through a SOX proxy?
Yes. So one of the listening modes for man-in-the-middle proxy is... Oh yes, sorry. The question was whether or not man-in-the-middle proxy can listen for traffic that you're already tunneling through SOX. So man-in-the-middle proxy can actually function as a SOX proxy server. So if your SOX proxy is set to just have another upstream proxy of man-in-the-middle proxy, then yes, you can watch it. So you split it in between more software that just speaks HTTP. And you have to get your SOX proxy to trust its cert. Probably should be relatively easy, but I don't know which SOX proxy server you're using. Good luck. If all else fails, if you've got all of this stuff handy, we can take a look at it later. Next question? 3.03, yeah. 3 days ago, 5 days ago, something like that. That's the one that crashes a lot on me. I'm amazed it didn't crash on me in this. I've been really careful to not hit the home key while giving this presentation.
Did that introduce a lot of new features or just iterative release?
Good question. Yeah, they basically did a complete overhaul on how things work. They basically manipulated things which were kind of opaque before. Trying to read the code of the built-in commands wasn't necessarily clear, wondering, hey, how'd they actually get these commands into this list for this view? How do those end up there? How can I bind my own? How can I get stuff to actually, how can I build new commands that I can run? And then once I have them, how can I run them? In this, all commands that are possibly to be executed, a lot of these are bound to those key shortcuts you just saw. All of those are found by man-in-the-middle proxy and can be loaded on the fly from script files, which are simple classes that take a request and maybe expose an add-on. So they basically overhauled a lot of these things so that you can actually see their guts, change them slightly, and maybe reconfabulate them to fit your needs if you have to, say, generate more requests, or maybe fuzz using man-in-the-middle proxy, which is I'm going to take a look at a request, I'm going to programmatically alter a lot of the parameters and see, hey, can I throw garbage data into this thing and get it to spit out data I shouldn't be able to see with, say, my user or my token. So, yeah, hopefully that answers your questions. There's a lot. Unfortunately, a lot of that brought some instability. So hopefully they're going to be stabilizing that quite a bit over the next month. Go ahead, Patrick.
Yeah, you had mentioned HTTP2. Could you talk more about this setup's compatibility with that standard?
It works perfectly. So if I were to load, I'm going to try and, yes, the question, sorry about that. So the question was about HTTP2, which is the most recent version of the HTTP standard. It contains a whole lot of things along the lines of multiplexing, like being able to send multiple objects in one thing, being able to send them even possibly before the client asked for them. You can serve them already and the client will just receive them and wonder what this data is and eventually understand, because say you're serving an HTML page. You need the introspector, the server, can introspect that data and realize, oh, well, if you're asking for this HTML page, you're going to want these images, this JS, this CSS. I'll just send it all to you. So it contains a whole lot of things around that and more that I can't necessarily get into. There's a great talk at, I think, either the most recent PyCon or the one before on all of the things coming in HTTP2. And in a lot of cases are already there. Nginx supports this and can do some of this stuff out of the box. A lot of CDNs already do this. So it's kind of important for man-in-the-middle proxy, if you want to watch that traffic, to be able to interpret this. I've got a dump. I won't load it because time. But basically, yes, it supports HTTP2. You can see the traffic. It shows up in this exactly the same way as HTTP1 traffic does. You can also apparently man-in-the-middle WebSocket requests, although I haven't done it, and even just plain TCP requests. Although again, I haven't done that either because I haven't needed to. Probably a lot more information in their docs on how to do that and what it shows up as. Next question? Say what?
What about UDP request?
UDP, I haven't seen any support for that. You might need a different tool, probably Wireshark.
There's no TLS in UDP, so.
Yeah. So fine, great. You can fire up Wireshark and just watch what's coming over the wire that way. This thing isn't all tools for all people. It was built to speak HTTP, and people jacked in WebSockets because it seemed like a good idea. People jacked in TCP because, hey, maybe I might want to watch Redis. Who knows? Next question. Ali in the back?
You briefly mentioned using this for testing.
Yes.
What are some of the strategies that you would use this for?
Sure. So one of those examples is basically record and replay. I'll capture a whole set of requests that I know my code's going to make with known input, and I'm going to set up man-in-the-middle proxy to replay that set of requests at a later date, probably when I'm running my test suite. Another way is if I want to make really sure that my test suite is not going out and hitting extra services, I'll man-in-the-middle my test suite. And then if I see any requests pop up in the man-in-the-middle proxy, I'll know, oh, I haven't completely done my job yet. I haven't stubbed out things that I should stub out with request mock or anything else. And that's actually one of the things I wanted to get into as far as the new architecture. Being able to create your own commands. One of those ideas I had was being able to grab a flow, say one I hadn't stubbed out yet, and have man-in-the-middle proxy generate me the Python code necessary to stub it out with request mock. You know, and that way I don't have to write as much code because man-in-the-middle proxy already has all of the details of the request and the response that it got back. So it would kind of help me with writing those tests. And originally that project I was on, we weren't allowed to write any tests. We had to have some stability in the thing. This was how I kind of provided some of it. At least there's a known set. I have to test with hardware devices I can only use once, and then they're forever modified. Crap. I should probably man-in-the-middle all the interaction with their back end so that I don't turn lots of things into bricks accidentally. Or, you know, I'm able to actually see the request before it really goes out to the real service. Any more questions? I think I have maybe one more minute.
Yeah, that's one.
Anybody? All right. If there's anything more in depth, I'll be in the bar.
Thanks again, Miles.
Cheers.
Yeah, it was fantastic.